All right, folks. So today we're just going to learn about acceleration. Now, remember when you were talking about speed or velocity? Oh my gosh, look at that. What was that? Speed or velocity? When we're talking about this stuff, we're talking about change in position per time. In other words, that's a time. In other words, how fast were they changing position? You know? The faster you're going, the more you're changing your position, the faster you're changing your position. Today we're going to be talking about acceleration, which is how fast it's change in velocity over time. So how fast are you changing your speed? Are you gradually just slowly speeding up, or are you speeding up really fast, like a rocket, So the actual equation, acceleration, is pretty much just your final speed minus your initial speed, which is technically your change in velocity, right? Change in velocity is... thank you. Thank you for the heads up. Yeah, I shared on the recording software, but not on this one. Thank you. Let's see here. There we go. And okay, so in velocity, like I was saying, it's change in position over time. Like how fast are you changing your position? So the faster you're going, the faster you're changing your position. In acceleration, it's change in velocity over time. How fast are you changing your speed? Are you gradually, like a really old car, barely speeding up, but takes a while? Or are you like a rocket ship where you're going from zero to something very quickly? So this is acceleration. And the equation is A equals VF minus VI divided by T. So technically it's change in velocity divided by change in time technically. Now usually this part right here, which is technically TF minus TI, your final minus initial times, we ignore it. They usually just tell you what it is. They don't usually say at T minus 10 seconds you're at this speed, and at T 20 seconds you're at this speed. They don't usually give you the initial and the final. They could, but they usually don't. They usually just say, hey, it took 10 seconds. So we tend to just write T. But be prepared. If you're in a physics class, they could totally just say what's the starting time and the ending time, and you'd have to subtract them here. But almost always you have to do that for the velocity, because change in velocity is equal to final velocity minus initial velocity. So what speed did you start at? What speed did you end at? Sometimes this is starting at rest, which would mean, I should just put that note here, rest means is 0 meters per second. You're not really moving. So sometimes you start from rest and sometimes you end. Depends. I don't know if you're slowing down or speeding up. But this was the equation right here that you're going to need to solve all the problems today. But we can rearrange it because sometimes they want to know what speed you end up at. See, final velocity. So we're going to solve for this algebraically. So we're going to times the t on this side and then add the vi. So is equal to initial speed, initial velocity, plus a times t. So if they want to know, hey, I started at this speed and I accelerated at this rate for this amount of time, this is the final speed you're going to end up at. So you'll end up going this speed, this new speed right here. And there's one other way you might see it today, and that's solving for time, and we're just going to swap these two right here. So we're going to get VF minus VI divided by A. So in this case, they're going, hey, you're going to go from this speed to this speed, and you're going to go there. You're going to change from this speed to that speed at this rate. How long will it take you, t? Okay, so we're looking at what speed you end up at, or how long did it take you to change the speeds, or just what was your acceleration rate. So it's one of these three problems, and I'll give you one example of each. Okay, so a car goes from rest to 40 meters per second in 10 seconds. What is acceleration? What is A? And so A is equal to VF minus VI divided by T. And so really it's the final speed, 40, take away the starting speed, divided by the time it took, 10 seconds, and that ends up being 40 divided by 10, which is equal to 4. And our units is this. It's meters per second up here, but seconds here. So it's meters per second. But we usually never call it that. We just call it meters per second squared. But you're changing 4 meters per second every second is what it means. So every second you went this much faster. You went 4 meters per second faster every second. So, but we tend to write just meters per second squared like that. Here's another one. So we're going to go from 10 meters per second. Here's a little car again. And it ends up going, let's say 40 meters per second. And your acceleration rate, so it's speeding up at a rate. It's a real slow car. It's only got an acceleration rate of 2 meters per second squared, which means it can speed up 2 meters per second. It can increase its speed that amount per second. Is what that really means. So the equation is t, and well, by the way, we're looking for t question mark, I should say, but it's kind of obvious I am because I told you what speed it started at, vi. I told you what speed it ended at, vf, and I told you the acceleration rate, a. Okay, the only thing I didn't tell you was time, so you kind of know that's what I'm looking for. Time is equal to final velocity minus initial divided by a, which is final minus initial divided by 2, which is 30 divided by 2, which is equal to 15. And we're looking for t, so it must be seconds, because that was the units I was dealing with. It was all seconds. Those were, all right? So that's that. And the last one we're going to do is this one here. We haven't solved for that, so let's do that on a new sheet here. New, no. So you got this car, and it's going on the freeway. It's a race car, let's say. And it's going 0 meters per second, so it starts from rest, and it zips up to some speed right here, this new speed. Its final speed is going to be what? What if I put a new engine in it, and my math says it should accelerate at 10 meters per second squared, which is ridiculous. I don't think there's any car that can do that, but let's just say it can. And it does that for like, let's say 8 seconds. So for 8 seconds, it can maintain that kind of acceleration. What would the final speed be? So this is like some theory, let's say. Like, hey, according to my calculations, we should be able to accelerate at that rate. What if we do it for 8 seconds? And we just started it for rest. What speed could we end up at? And then you'll say, oh, final speed is equal to starting speed plus acceleration times time. Okay, so final velocity is equal to starting speed plus a times time. So 80 is equal to VF. What unit? Well, this is a velocity. And velocity units are meters per second. Acceleration is meters per second squared. T is in seconds, okay? So this would be a meter per second. That's how fast it'll be going at the end. And that's it. Your work is going to be over here in acceleration right here. And it's only 8 problems, I think. No, 5 only. And the equations are here, but written a little funky because it's in Microsoft Word. But you can always look at this video and use those equations. It's the same thing. It's final velocity minus initial velocity divided by time. Time is final minus initial divided by acceleration. Or final velocity is acceleration. Acceleration times time plus the initial velocity. So it's just reversed. I added it to begin with, but it's the same exact equation. Make sure you show your work for full credit, and that's pretty much it, folks.